Okay, so for this video, we're going to look into some trigonometry. It's a more advanced side of trigonometry. It's more involved. So yeah, let's jump into it. Which one of the following options means exactly the same as sine x over 1 minus cos x? Okay, so we want to know sine x over 1 minus cos x. Which of these five options is the same as this? Okay, so we'll see that here's something. What is this? This is an abbreviation which most likely you haven't seen, and all it means is cotangent of x, which is the same as, we simply refer to it as cot x. Okay, or you know it as cot x. So CTG of x equals to cot x. Okay, we go through another one. This is pretty self-explanatory. CSC of x. This is the cosecant of x, which we know as cosec. So CSC of x simply equals to cosec x. Right? Okay. Then there's another one that is not familiar, and that's TGX. This is simply the tangent of x, which we just shorthand tan x. So TG x equals to tan x. Okay, so the rest is pretty self-explanatory. So now that we got that out of the way, let's find out what we need to do in this problem. Okay, so firstly, we need to look at a concept that we're going to be using, and it's called normalization. So in mathematics generally, what we try and do is we try and keep the denominator as simple as possible. What do I mean by this? If you have something like this, 1 over 1 minus root 3. In maths, we generally don't like the denominator being as complex when we can add complexity to the numerator and take away some of the complexity of the denominator. Let me explain. So what we generally do is we use the fact that if we multiply anything by 1, we get the same thing back. We still get 1 over 1 minus root 3 back. So what that means is that we can make sure, or we can have 1 mean anything, and it will still be the same, but it will look differently. So if, for example, we can make 5 over 5, we can multiply this with 5 over 5. We can also say, for example, which is still 1, we can also multiply this by x over x. This is also 1, so we'll get the same value. So what we do in maths is that we do something called normalization, whereby we take the complex denominator and we do something like this. We multiply it by its conjugate. So what does the conjugate mean is that the conjugate is, you'll see that over here we have a minus and over here we have a plus. So the conjugate means that we invert the sign. Okay, so what happens here is that we get something like this: 1 plus root 3 over 1 minus root 3 multiplied by 1 plus root 3. Now the reason we do this is that in many cases we get this, which is what we want. We want the section to look like this. Why do we want to why do we want it to look like this? Is because if we go back to factorization, there is something that looks like this, and it's called the difference between two squares. So if you have something like this and we factorize it, we get x plus y and we get x minus y. It looks like its conjugate, right? So we can see that we have a conjugate pair here. So what we can do is, we know that the answer is x squared plus y squared. So in this case, x squared, or x equals to 1 and y equals to root 3, if we want to apply it. So what does this look like? we have 1 plus root 3 over 1 minus root 3, 1 plus root 3. And according to our factorization approach, this equals to something like this. It's 1 squared minus root 3 squared. Right? And this gives us 1 plus root 3 over 1 minus 3, which equals to 1 plus root 3 over minus 2. Now what we must remember is that this and this are the same thing. The value is the same because we've just multiplied it by 1 throughout. This is 1, that's 1, and we've just multiplied it by 1. So the value, the physical value of this, we did not change anything around the value. Okay, so this is normalization. This is why we do it. This part right here is much simpler than this part mathematically because the denominator is simpler. Okay, so how does that tie into our problem at hand? We took a massive detour, but I think it's something that I needed to explain before we can go on. Okay, so we are going to normalize this because our fraction has a complex denominator. So how does this look like? 1 minus cos x. We multiply it by its conjugate pair. So we multiply it by 1 plus cos x over 1 plus cos x. Remember, this is just 1. We are just window dressing. It's the same value. It's just 1, and we are left with sine x 1 plus cos x, and then like we said, it's 1 squared minus, let's put some brackets, 1 squared minus cos x squared, right? So this is what we're left with because factorization. Okay, so we are left with something that looks like this: sine x 1 plus cos x. We're going to leave this for now. We're not going to multiply it out because we want to keep them separate for now. Should we need to multiply it out later, we will do that. 1 minus cos squared x. This part looks very familiar, doesn't it? It looks familiar because sine squared x, sorry, plus, I'm going to run out of space, just give me a second, let's move it. Sine squared x plus cos squared x equals to 1. We know this, so if we rearrange this equation, we'll see that sine squared x equals to 1 minus cos squared x. Okay, so we'll see that this is the same as that, so we can simplify this, or we can change this to look like this. Sine x, let's write the top, 1 plus cos x. We still leave that as is, we're busy focusing on the bottom, sine squared x. Okay, so now what we see now is that we've got I'm going to continue on the next page. Sine x 1 plus cos x all over sine squared x. Okay, so what we can do is that, and we are left with 1 plus cos x over sine x. Okay, so now we're at this point. The next step, or the next part of what we are going to do is this comes with practice. You need to do enough of this to see this. I usually use the analogy of trying to make coffee in a stranger's house. Because you experienced in making coffee at this age, I surely hope, you know that where the kettle is, there's most likely going to be the sugar, and the coffee is not going to be very far off, most likely. So the same thing applies in maths. You know where to go look once you've gotten used to the concept. So what we're going to do here is that we are going to say 1 over sine x. We're going to break up this fraction, plus cos x over sine x. We're going to break up this fraction into something like this, and now we have our answer, because 1 over sine x is simply cosec x, and cos over sine x is, we know that sine x over cos x equals to tan x. We know this. This is knowledge, okay? Common knowledge. So if we invert this, we can see that this is the inversion of that, because here it's cos x over sine x and here it's sine x over cos x. So what's the inversion of tan x? So we need to say that if, let me just write this over here, sine x over cos x equals tan x, then cos x over sine x, we inverted the one side of the equation, so we need to invert the other side of the equation, and this is simply equal to cot x, right? So cot x. Okay, so if we go look at our options, we're done now. This can't be simplified any further. This can't be changed into anything else, because we're trying to move towards a certain point. So if we go to our answers, we can see that, wait, what was it? Oopsie. Cosec x plus cot x. This is our answer right here. Cosec x plus cot x is our answer. So let's go see if, there we go, that one. Cosec x plus cot x. Remember, I explained the whole abbreviations at the beginning. CSX is cosec, and CTG is cotangent, or more commonly known as cot. And that is how you solve that problem. Thanks for watching.